All right. Not sure how great the title is here, Conceptual Derivatives, but one thing I've noticed on the AP test, a lot of times they expect you to be able to take the derivative of a function without actually identifying what the actual function is. So, which is kind of a weird thing I just said, but like for example, something like this. You know, y is equal to, let me just start with something real simple, like h of 2x. Okay? So they might give you something as opposed to saying, oh, y equals sine of 2x, or y equals whatever. They'll say y equals h of 2x. And, you know, for whatever reason, you'll have to take the derivative. Okay? So we need to know how to be able to deal with this here. Okay? So in this case, it's a chain rule problem. So we'd have a y prime is equal to, and then we'd have, okay, you'd start, you know, h is the outer function, 2x is the inner function. So the derivative of h would be h prime. That's the first thing we do. We'd keep the inner function the same, 2x, and then at the end multiply times 2. Okay? So that would be the derivative right there. Okay? This is a fairly simple one, but again, you know, I've seen many problems where they will set it up in this manner as opposed to just giving you sine of x to test your ability of working with derivatives. Okay? Let's just take a look at another one here. So you might have something like this where it's y is equal to, say, g of 3 minus x squared times sine of 2x. Okay? So here's an example where we're going to use the product rule and chain rule. Okay? So, and our goal right now is to find the derivative of this function. Okay? So we have two functions that are multiplied by each other. That's why we're using the product rule. So you have g of 3 minus x squared is one function. The other function is sine of 2x. So I know for the product rule I have to find the derivative of each of these, so I'll do that. So this is going to be, start with my outer function first, g. The derivative of g is g prime. Keep my inner function the same. And then at the end multiply times the derivative of the inner function, negative 2x. Okay, so that's the derivative right there of g of 3 minus x squared. Over here, the derivative of sine is going to be, derivative of sine is cosine. Work with that first, keep my inner function the same. And then at the end, I'll multiply by the derivative of my inner function, which is 2. So now, again, I'm just kind of setting up so I can apply the product rule. So then my derivative would end up being, you know, this function times the derivative of this one. So it's the g1 right here times the cosine one. So let's see here, I guess the 2 I'll put in front. 2 times g of 3 minus x squared times cosine of 2x plus, and then I'll do the sine function times the derivative of the g, so this guy times this guy here. And again, I'll put the negative 2x in front, so I'll make it minus 2x because of that. Times g prime of 3 minus x squared times sine of 2x. So that one's kind of nasty right there, okay? But, you know, you can see how that works out, okay? Now, we could also do something like this. Let me just do one more example here. Say you had y is equal to, say, sine to the 5th of h of 3x, okay? Something like that. So for this one, I'd recommend starting like this, with y is equal to, put some parentheses around the whole thing. I need one more parenthesis to the 5th. So it's the same thing, just, I don't know, I think it's easier to work with this way. So my outer function that I'm going to start with is the to the 5th power. So when I start taking my derivative using my chain rule, I can bring the 5 down in front, keep my inner function the same. So that whole inner function, sine of h of 3x, is kept the same. Okay, and let's see here, I need one more parenthesis here, and subtract 1 from my exponent, okay, to make it 4. Now I have to multiply by the derivative of my inner function. Now my inner function, and I'll write it over here separately just to make it a little easier to work with, is this whole sine of h of 3x thing. Okay, that is my whole inner function right there, so I've got to, when I multiply by the derivative, I've got to multiply by the derivative of that entire thing. So I've got to be careful here, because there's crazy chain rule going on. So first work from the outside. The derivative of sine is cosine. So cosine of, keep my inner function the same, h of 3x. Okay? And then I have to multiply times the derivative of the inner function, which is right here, h of 3x. So the derivative of h of 3x would be h prime of 3x times the derivative of that inner function, which is 3. Okay? Whew. A lot of inner functions going on there. So, again, I did this off to the side, but what I was doing a second ago, I brought the 5 down and kept my inner function the same, subtracted by 1, and then I would have to multiply by the derivative of this inner function, which I just found was this. So let me just move this down here, so it'll be times cosine of h of 3x times h prime of 3x times 3. And I don't think I'm going to rewrite that because it's kind of ugly, but you could combine the 5 and the 3 to be 15 and so forth, but there's the derivative right there. So that's an example of a few conceptual derivative things.